Hi audience, hi everyone, great to see you all. Hi guys, yeah. Welcome to Tani Class, Tani Classroom. This is my channel from Twitter. Great to see our audience, even though now is a zero viewer. Okay. Let's get started. Today, I want to teach you about mathematics. Yeah, what is mathematics? I am a professor. You see this guy? Yeah, it's a linear combination. Today, listen, we will talk about the linear combination. First thing, I would like to show you about the definition. Yeah, definition. You see this? You see this one? Yeah. V1, V2, or V3, V4, V5, V2, Vn, or any vector. This variable we call the vector. Yes, vector that we suppose that. Yeah. All right. The definition of linear combination is the multiply the any scalar, any number, multiply the any number of scalar to the vector that we have. You can see, yes, this variable a is a scalar. It can be the negative, positive, and zero. Yeah, as you can see, the linear combination is the vector multiplied by the scalar. Yeah, where the scalar that you use it to time with it is any scalar have to be the subset of real number. Okay, this is the definition of linear combination. The scalar times by vector. Yes, as you can see this form. Yeah, I will show you. Next is the example. First example, yeah. Suppose that we have the two vector. Yeah, first vector is u. Yeah, another vector is v. This vector have 0, -3 and 5. Yeah, another vector is 1, 4 and 7. Yeah, and this question they ask that find the linear combination of 3 times vector u plus 4 times vector v. How can we do? It's very easy. We just put this 3 times to the vector u and change it, vector u into the form. We will get this. This is a vector v. This is a vector v. This is a vector u. Is time each other. Yeah. The next method is very easy. This one, you will see the answer we will get 4, 7 and 43. How to do is just the first row. Yeah, how to do is you use 3 times by 0. You will get what? You will get 0, and you plus with 4 times with 1. You will get 0 plus 4. What do we get? Yes, exactly, Mr. Tanawat or Mr. Ka or Mr. Witchayut. I don't know who, or Mr. Pan also. Thank you. But yeah, the first one is come from 0 plus 4. We will get 4. Yes. The second row, how to do? Very easy. You look at the second row. Yeah. You will see this guy. Yeah. 3 times by -3, you will get -9, and plus with 4 times 4, you will get 16. When you plus it each other, you will get 7. Easy. And the next method is the same. You look at the third row. You will get 3 times 5 plus 4 times 7. You will get 43. Yeah. This is the answer. So the linear combination of 3 times vector u plus 4 times vector v, you will get this answer. Yes, is 4, 7 and 43. Yes, this easy, right? Very easy. And the next example, really easy too. Is it the same vector? As you can see, it's a vector u. Yeah, 0, -3 and 5, and vector v is 1, 4, 7. And yes, this is the question. Is this vector, what a vector? Vector 2, 6 and 31. Is this vector a linear combination of u and v? how to do? How to check that what is this vector is a linear combination with vector u and v? How to do it? Have two way. Yeah, I show you two way. The first way, the form last example. As you can see, we will write it into this form to this form, right? And we just suppose that uh, something time with a vector. This is a scalar time with vector u, and another scalar time with vector v. You will get this from the question. Yeah, this is a definition. Yeah, we suppose the A to be the unknown scalar and B to the unknown scalar too. Yeah, so how to do is easy. You just do the same as the first example, just like A times 0 plus B times 1 equal to 3. So you will get the first equation, as you can see. 0 times A, you will get this one, so it would be 0. And B times 1, it would be B and equal to 3. Yeah, you will get B equal to 3, the first equation. The second and third equation is same as first question. Like you use A times negative 3 and plus with a B times 4, you will get 6. The third equation is same as second equation. You will get this 3 equation. So you just solve it. Very easy. Very easy. Thank you, Mr. Witchayut. Yeah, Mr. Tanawat. But again, thank you for donating, even though you not donated yet. Thank you, though. Thank you. And yeah, you solve the equation. You will get a b equal to 3 from the first equation, right? And you just use b, put it into second equation or third equation. So done. You will get the same answer, like A will be the 2. So the is you will get A and B the scalar, but that time to the our vector is 3 and 2. So the answer would be something like this: 2 times 0 negative 3 5 plus with 3 times with 1 4 7. You will get 3 6 and 31. When you do this method and you get the answer, like you can find A and B, or you can find the scalar that time with your vector. That means this vector is a linear combination with your vector, like u and v. So another method is low echelon. Very easy. You just you see vector u and vector v, right? And you write it into the metric form. Yeah, you just you see u, yeah, you put it into first column. You will get this. All of it is vector u, right? That, and this is vector v, and you just boop, and this one, what it is? It's come from your question. So this, you will get a metric something like this, and you just do the row echelon method, and you will get this one. So you, as you can see, this is a b, right? B equal to 3, the first equation. You write as the term of equation, you will get b equal to 3, and this one is a, right? You will get a equal to 2. As you can see, a equal to 2, b equal to 3. We will give the same answer with the first method. So it's done for lesson today. Thank you for visiting me today. I'm very grateful. And next to the second lesson by my friend. He is a celeb and popular guy. Thank you everyone. Thank you. I love you. Bye bye.
So, hello everybody who is today. Today I will be teaching linear combination part 2. Okay, so it's the continuation of what the Thanphisit has taught us. So now I have come up with 3 equations. So let's do it. So the first, solve linear equation. So let me change it so you can differentiate it of what I on the screen. So let me go for orange. Okay, so to solve this equation, I'll be using the row echelon form. We can like 1 minus 7, negative 10, row 5, negative 8, 11, 2, 5, 29. First, let me reduce, delete all the first number into 0, and leave only 1. So let me add. Let's add 1 to row 3 with negative 2. So we got negative 2, 14, 28, 2, 5, 29. So now we got 0, 19, and what's the answer? The last one? 57, 57, 50. Okay, so now we 0, 57 for the row. But you can see that 19, 57 is divisible by 19. So we can reduce it to 0, 1, and 3. So now we got 0, 1, and 3 for the third row. And now let's do it to the second row. So let's add 1 to 2 by negative 5. So now we got negative 5, 35, 35, and the last one is 70. And now 5, negative 8. Now we add together, so now we got 0, 27, and the last one. What's the answer? The last. I'm waiting for you. The last one. 7, 81. Oh, thank you, Mr. Thanphisit. That's correct. And I see that 81 can be divided 7. That says now we got 0 and 3. 0, 1 and 1 and 3. And the first row 1 and 14. And now you can see that after we add the first row to the second and the third row, the answer is the same. Interesting. Now, what if it is the same? So we cut it into one row. So now we got 1, negative 7, negative 14, 0, 1, and 3. And we can put the last row into all 0. And now we left 2 rows. See. Now let's do it. So let me add row 2 to row 1 by 7. So now we got 0, 7, 21, 1, negative 7, and negative 14. And now we 1, 0, and 7. So 1. Okay, so let me use this. Okay. So now all can see what answer. What is the value of x and y? Value of x and y. So the values here is that x equals to 7, y equals to 3. This equation, there is a solution for this equation where x equals to 7 and y equals to 3. Easy. So now let's proceed to the next equation. So let me copy and move to the new. Okay, so let's do the row action again. So okay, so you can see that here, last column, the leading one is not in X, Y, and like last column. So what does it mean? So are there any question, any answer? Does 1 in this place mean? I think that's incorrect. I'm waiting for. What does it mean? No answer. That's correct. So the equation, there is no solution. Equation. So one step has solution, but another solution. Interesting. So let's try the last equation. Copy this. And paste. Here, boom. So we do the method again. This equation has no solution. So from all these equations, like how to think with the combination, this vector, another vector, and this one, that's the last vector. So remember, if there is a solution for that equation, it means that the last vector here, negative 14, 11, and 9, is the combination of these two. But the other hand, if there is a solution like this, like for question 2 and question 3, it means this vector is not a linear combination between these two vectors. That is the part 2. So what's your thought? Is it hard? Is it easy? So now we will be leading to the part 3, which was centered by my dad. That is the end of our lesson today. So don't forget to like, share, and please subscribe to my channel. And that is the end of our today's lesson. Bye bye.
Hello everyone, my name is Pan Piyatassakorn and I'm here to introduce you to what is span and how can one vector belong to the span of another vector. But before everything, you have to understand what is span first. So in short, span is the set of all linear combination of V1, V2, V3 and up to Vn. And to ask that V1 belong to the span of V2 and V3, V1 must be the linear combination of V2 and V3. So now let's have a look to this question. Let V1 be vector 5, 1, 6 and V2 be vector 7, 2, 3 and determine if the following vector belong to span V1 and V2. So this is vector 1, negative 1 and 12. First we write this down. A vector 5, 1, 6 plus B vector 7, 2, 3 equal to vector 1, negative 1, 12. And then we have to calculate to get the result to be like this. Okay, so first we subtract row 1 with 5 multiply row 2 and subtract row 3 with 6 multiply row 2. Then we got this vector, and then next step we subtract row 3 with 3 multiply multiply row 1. Yeah, so we get the result that is 0, 0, 0 on row 3. So now we will multiply row 1 with negative 1 over 3. Then we get the result of this row 0, 1 and negative 2. Then last step we subtract row 2 with 2 row 1 and we get this. So we got that A equal to 3, B equal to negative 2 then this means that vector 1 minus vector 1 เท่าไหร่นะ1 2 3 and we get that vector 1 negative 1 12 is a linear combination of v1 and v2. Then this means that vector 1 negative 1 12 belong to the span of v1 and v2. Okay, so this is the example of the vector that belong to v1 and v2. So now let's move on to the another vector that also belong to span v1 and v2, which is vector of 0 0 0. So now let's move on to another vector that is belong to the span v1 and v2, which is the vector of 0 0 0. Since the vector of 0 0 0 is a vector that we can modify 0 into v1 and modify into v2, so it means that vector 0 0 0 is belong to the span of v1 and v2. Right. So now let's move on to our last question. Is the vector of 1 to 0 belong to the span of v1 and v2? So we write the same thing as the question 1, which is A vector 516 plus B vector 723 equal to vector 1 to 0, and we get this matrix. Okay, so now we're gonna calculate this one. So we subtract row 1 with 5 row 2 again, and subtract row 3 with 6 row 2. Then we get this result. And next step, we subtract row 3 with 3 row 1, and we see that it is 0 plus 0 equal to 15, which is not true. So we can conclude that vector 1 to 0 is not a linear combination of v1 and v2. Therefore, the vector 1 to 0 is not belong to the span of v1 and v2 too. Okay, so thank you for everyone, and let's move on to our next part.
Hello everyone, welcome to the part 4.4, and let's go to the first question. The span of the vector 0, 1 is the subset of span of 0, 1 and 1, 0 here. And first we have the A times 0, 1, where is the A is a real number, and we have the vector 0, A, where is A is a real number. And let's to the right hand side, and the right hand side we have the A times 0, 1 plus B times 1, 0, where A and B is a real number too. And we have the vector A and B, where A and B is a real number. And next we have to see the graph, and the graph, the left hand side is here. It's a 0, 1, and the graph, the left hand side is here. Yeah, now you see. And these two vectors basically the span the empty plane, so obviously the span of 0, 1 is the subset of span of 0, 1 and 1, 0. Okay, it's very easy. No, I'm not Indonesian, I'm Thailand. Mahidol is my university. Oh, hello, Mr. Witchayut. And the next question is very easy. And the vector 1, 4 is the element of span of 1, 0 and 0, 1. The question is very, very easy. No, I'm not gay, Mr. Tani. First, we write the vector 1 and 4, and we got the 1 times 1, 0 plus 4 times 0, 1, and now you see the vector here is the same vector, and the vector is automatically belong the span of 1, 0 and 0, 1. It's very easy. Yeah, it's very easy. And last question. The span of 1 0 and 0 1 is equal the span of 1 0, 0 1 and 1 5. So the left hand side we have the A times 1 0 plus B times 0 1, and A and B is a real number. And the next line we have A and B is a real number. Go to the right hand side. The right hand side we have the A times 1 0 plus B times 0 1 and plus C times 1 and 5. So ABC is a real number. And next line we have the A plus C and B plus 5C, and ABC is a real number too. You love China? I love China too. And the right hand side is not bigger than the left hand side because A and B is a real number, and here A and B is a real number too, because the left hand side can't put any real number, and these two guys is the same thing, and we get this. And next part we will expand to the example 4.5 and 4.6.
Hello guys! Hello! You know who I am! You know who I am! I am a super thief! Don't forget to, if you see me at the road, your wallet and your money will be mine. Your motorcycle will be mine. And the last one, your girlfriend will be mine too. But not important today. My name is P, and today I have to teach you mathematics. But I've got 5 minutes before I go rubber again, okay? 5 minutes. So why don't we see our example today? Let's start with example 4.5. Show that the second derivative of 5x and 5x plus 18 is 0. So the first one here, if you see 5, first derivative of 5 is 0, yes. Second derivative of 0 is also 0 because it's a constant already. For the x, first derivative will be equals to 1 and the second derivative will equals to 0. The last one, 5x plus 18, you see that the first derivative it will equals to 5, and then also like this graph it's equal to 0. Easy, right? That's mathematics, guys. And the second one is fx equal to a times 1 plus b times x plus c times 5x plus 18. The general solution to the differential equation f double derivative equal to 0. Let's see. If you see at the last term here that I highlighted, you can see that it's 18 times 1 plus 5 times x. Sorry. Okay, you can see that now. And yeah, that is much like here and here. And if you take a look, for the last term, we don't consider it because all these have nothing to do with, for the second derivative, we only focus on this one. And the f double derivative, it will equals to this one. Right? Okay, 2 of them has gone. Now the last one. Whoa, time for robbery is coming. Now let's see this. Putin would like to find the average height of Russian soldiers. He collects 5 samples H1 to H5 and make up 10 additional data, just as you can see here. Too much. What is wrong? we'll say for the population of the soldier from Russia, I don't like them. They're in Ukraine now. I hate them. Yeah, the average is male for the population, but we cannot find them all from the whole army. So we can find just the sample, just 10 or 5 or anything, and the average is X bar. Yes, and if you take a look here at the first one, or all of them, L is the same. Don't worry. For the first one, no, sorry, my fault. It's supposed to be X, no, H. Yeah, H1 and H2. If you see at these one will appear like this. But as you can see, the data is just the same from the one that Putin has correct here. So it's just recycled data. And if you see 15 data, as the question stated earlier, 5 and then 10 additional, so it's 15 datas, and we just know that it's just 5 of them, so there are 5 real data for all this example. Thank you guys. Time's up for my robbery. Remember kids, if you see me at the road, you must run, okay? Otherwise your money will be mine. God damn! It's not mine. Whose is this? What? It's my ankles? Holy shit! His balls smell so bad. I don't want to be a robber anymore. Fuck it.